Question: a square shop sign of uniform density has a mass of this and the sides of length given. There is a frictional force in the hinge so that the sign hangs from the equilibrium at an angle of 15, but you have to find movement about the hinge of the weight of the sign. Okay, so if we zoom in into this problem, the weight will be acting exactly at the center because it's a uniform sign, right? So weight will be like this. So this is the point where the force is acting. And okay, so you have, this is the pivot point. Distance from the pivot till the force, this is, if total is 0.86, this will be equals to 0.43, half of it exactly. Okay, now what we have to look at, if you remember the definition of movement, it is the force multiplied by the perpendicular distance, right, to the force. So we have to find the components of this weight. There are two components of this weight. One will be the perpendicular to the surface, like this, and one will be along the surface, like this. Okay, we are not interested in this because of this component, the line of action is passing through the pivot point. It will not produce any movement. We are interested in this thing. Okay, so this is, if this is weight, this will be the angle theta, this will be mg cos theta. Okay, the most common mistake, student consider this theta as 15 degree. That is wrong. Why that is wrong? If you look at this thing is making a triangle. Okay, let's draw it here. This thing is making a triangle where it's, this side is 0.43, this angle is 15. Okay, so, and this angle is 90 degree. Okay, this angle theta relates with this angle, not this one. So you have to find this angle of the triangle. Okay, if you remember the inclined plane model, if there is some inclined plane, if this is angle theta, the weight will act vertically. Let's suppose the object is here, the weight is acting like this, the perpendicular component is like, this angle will be theta. We never said this angle will also be equals to theta. This is not the case. This angle and this angle will be the same angles. Okay, so you have to find this. This is 15, this is 90, so this angle will be 180 minus 90 minus 15. That thing will give you 75 degrees. Okay, so this will be, this force is basically m is also given. This force is 2.4 into 9.81 into cos of 75 degree, and the distance is already given, so movement is F into D. This is 2.4 into 9.81 into cos of 75 multiplied by 0.43. This thing will give you 2.62 Newton meter. Okay, it's option A.